left at all. I think more and more people are getting to realise that this nurse is sitting in prison without having done anything wrong. No, there's nothing, but that's the question now is a different one. The question is, how can she be released from that situation? And of course,
to ask where we go from there, because last time we spoke, and we spoke about the case in some detail, I made the statement that, as far as I was concerned, I had an open mind on the matter. I didn't know whether she was guilty or whether she was innocent. You were more convinced than I was, but I have to say that having seen this particular evidence that you presented now, I've changed my mind on that. I have to say that I don't think that she is guilty. Certainly, I don't think there is any evidence which is beyond reasonable doubt which would convict her in any honest court of law.
And people indeed that I know who have changed their mind. I mean, I knew people who are absolutely convinced of her guilt and are changing their minds. So I think public opinion is changing.
John O'Quigley is a specialist academic in statistical analysis. He is professor at University College London. He's worked at the University of Paris and the Sorbonne, the University of California in San Diego, University of Washington, Seattle, and the University of Virginia Medical School, and also the Department of Mathematics at Lancaster University. And he's got more publications to his name than I could count. So, John, this is the second time we're meeting, and welcome back to the podcast.
Thank you very much. Thank you very much.
Last time we spoke about the Letby case in particular, and we want to concentrate on that today because a lot's happening about Lucy Letby, particularly in the papers at the moment. Can you bring us up to date as to what the state of play is on that case? I know some of the evidence has been questioned.
Yes, I'm probably not the very best person to go into all of the details, and particularly the medical details of the case. Of course, I have been following it. And I think just a day or 2 days ago, Dr. Shu Lee from Canada gave what I consider to be a rather explosive presentation, which I think we can say utterly demolishes the prosecution's case from a medical standpoint. I think what Dr. Lee managed to do was to get together essentially the number one group of neonatologists in the world that could be found, including himself, of course, who is a very highly reputable scientist and neonatologist. And they looked at in collaboration with Lucy Letby's attorney, Mark MacDonald, they went through the case notes in great detail. Now, I don't think anybody could challenge the degree of knowledge and competence of this team that was put together. They went through all of the, I believe, or certainly most of the cases, and I think they continue to work on the cases, and they just utterly demolished the theories that have been put forward or that were used to get a conviction against Nurse Letby.
These are 14 neonatal experts from around the world.
From around the world, yeah.
Here, isn't it?
Yeah. I think that's why he took them from around the world. I think his only criteria was to get the absolute top, the very best. So it makes it rather difficult to challenge. I think their degree of competence and expertise is simply beyond question. And they very carefully, diligently, and working closely with Lucy Letby's attorney, Mark MacDonald, they went through the notes and looked at the evidence very carefully. And of course, they went beyond that and they looked at the conditions surrounding the Countess of Chester Hospital at the time, and reports such as the report of the Royal College of Pediatrics and Child Health. They had a report in 2017 or 17, I think, which really detailed a very large number of shortcomings at the hospital. Shortcomings that would inevitably pose a threat to those very fragile babies that they were dealing with. So I think they looked at a number of these things. As far as I can see, I'm not a medical expert. I have no medical training. I'm a mathematician. But as far as I can see, everything that is coming out from this report is utterly damning to the prosecution's case against Nurse Letby.
They've concluded, haven't they? Basically, they've concluded that there is no medical evidence which stands up against her. But what they didn't look at, it seems to me, was the statistical evidence. There's a gap here. And I wanted to follow up with that because this is your field and your area. And I wanted to follow up one thing that we didn't have time to discuss last time when we had the interview was I suggested that maybe this was just a matter of Lucy Letby being in the wrong place at the wrong time. And you said you disagreed with that. And could you say a bit more about it?
Yes, the reason I disagree is I believe that she was in the right place at the right time, rather than the other way around. And I will try and show that with a few slides. But in actual fact, what Lucy Letby was doing, she was doing her job, a very dedicated nurse. She was working long hours. And because of the amount of time she was on duty and because of her devotion, dedication, and the fact that she had become, young though she was, she had become more senior because they were getting rid of the very senior nurses. She was one of the most experienced there. So she was taking on the more fragile cases, or at least she was going to be present there for many of those. And certainly purely by virtue of the amount of time she worked, she was going to be there. And I will try and show that from recent work that I've done myself. And if we look at that work, what it shows is
Can I just bring up the first slide then? This is the if I remember correctly, this is the slide which really everything seems to have been based on the idea of the shift chart. You know,
yes,
that
yeah,
Lucy Letby was around at the time when all these children were being injured or had problems and difficulties, and some died. And she was the one who was identified as being there each time.
that's right. That's right. And this chart is thoroughly misleading. I'm not the only person to say that. Other statisticians have pointed out the fact that this chart cannot be relied upon at all to show what the prosecution and the police were trying to show. And what they were trying to show was that when something happened, a so-called suspicious event, and let's keep in mind, a suspicious event is only something defined by the prosecution's expert witness. We don't know objectively or precisely what is meant by a suspicious event, but let's just go with Dowie Evans's definition, whatever that would be. He comes up with his definition of a suspicious event, and they broke down a collection of 61 events, occurrences, of neonates, and they broke them down into 25 he deemed as being suspicious and 36 he deemed as being not suspicious. The
Well, I mean,
fact,
looking at the chart, I'm sorry to interrupt, but looking at the chart on the surface of it, there is Lucy Letby with an X against every single suspicious event. All 25 of them are listed down there. She's there all the time. She's the only one who's there all the time. And that was what was presented to the jury. So why would that be not conclusive evidence?
well, it is smoke and mirrors, actually. This is something of a mirage. It is not what it appears to be. And I would have been among the first when I saw this chart. I would have been among many others who saw the chart and said, "Wow, wow, that looks like smoking gun evidence of something wrong with Lucy Letby." But in fact, it's nothing of the sort. And to obtain that, we need to do a little bit more work, not a lot more work, but we need to do a little bit more work. Now, the first thing we can say before doing that bit of extra work is to say, where did this chart come from? Now, many, like myself, statisticians, have complained that we don't know how the chart was put together. We suspected that there was a lot of cherry picking going on. Well, we know there was a lot of cherry picking going on. This was not denied by all sides, that the cases being put in there were those cases involving Lucy Letby. In fact, the definition of suspicious, really, if we had to write a definition down, it would be a definition that included Lucy Letby. So we knew already that the compilation of that chart was involving information about the presence of Lucy Letby. So, of course, it is something of a circular argument when you end up showing, well, she is always seems to be there when something happens. But
okay, you mentioned there were 60 odd events in total.
61, yeah.
61 events, and yet this chart only shows 25.
Exactly.
And have those 25, you're saying they've been chosen because those were the 25 which Lucy Letby was actually at, and the remaining 30 odd were not put in because she wasn't present. Is that the point?
Something like that. Something like that. It's a little bit more subtle, but this chart was put together by a number of people. There were the consultants, there was the police expert, Dowie Evans, and the police themselves. Now, we suspected, and I said this actually in one of the papers I wrote, that that chart would have been the result of iterations, that to get a chart like that was essentially impossible. And I said that at the presentation I gave to the Royal Statistical Society at the end of last year, that you could not obtain that chart in the way we believe it was obtained, or the way it's implied that it was obtained. It is
why was that? Well, why can't it be obtained in a straightforward way?
Because the probability of selecting, if we look at the 61 cases, 25 of them are suspicious and 36 are considered non-suspicious. If we look at this as a diagnostic problem and we look at the best accuracy techniques available to the leading diagnosticians in neonatology, you simply could not obtain that degree of correspondence. I think I've forgotten the calculation, but it's something like 1 in millions. It's just not possible. Okay. And in fact, what did happen...
Clarify, because I want to get this clear. 60 cases are brought out where something bad has happened. But only... Now, some of those cases could be due to mistakes. They could be due to unfortunate circumstances. But out of those 61 cases, 25 were selected as being suspicious. 61 are things where harm takes place. 25 are suspicious. And the point that you're making is, in the instance of selecting those 25, Lucy Letby's presence actually helped to choose the 25, or contributed to the choice. The fact that she wasn't present, they didn't choose them.
Well, to some degree, yes. It was more complex than that, but I think that's what it amounts to. And we saw very recently, this is just days ago, I think, from David Rose, I believe, at the Unheard. It's a site, I guess it's a news outlet, and he showed that we have this same chart, but there are holes in it. And that's how it started out. That's how it would have started out. There would have been several holes in it. And I did make the point also in the paper, a single hole, one single hole in the chart, and it all collapses. Why? Because it would not be overwhelming evidence of Lucy's presence that would sway the jury. If there is a suspicious event, and she is not there, then that raises a lot of questions. You'll say, well, how do we define a suspicious event? So already there's going to be some doubt about the accuracy of that definition, or we can really believe the definition is accurate 100%. And then the question is, well, something suspicious took place and she was not there. So what does that mean? Does that mean that somebody else is acting in a nefarious way? What would the explanation be? And of course, there could be a lot of discussion around that, but one single hole in that chart, in that line against Lucy Letby, one single hole, and I think the whole thing falls apart. So that chart, and by the way, a lot of people don't realize this, and I think that the Cheshire Police was more or less claiming that this is somehow an invention of theirs, but it's not, because this chart has been used many times. It was used in the Lucia Dept case. It was used in several other cases. And this is almost like a blueprint. You have what you believe is a spike. The next thing you know, you have what you believe is a potential culprit. And the next thing you know, you have a chart like this, and the chart is always 100%. So their argument was, we have 25 cases here, and she was there for all 25. So the probability of Letby being present, according to their calculation, would be 25 divided by 25. This is 100%. Well, that does sound rather striking, doesn't it?
Yeah.
But in actual fact, that chart was the result of a number of iterations. We don't know how many. This is still something of a mystery that would be nice to shed some light on, I think. But certainly the initial stages of that iteration, there were holes in the chart. And that was brought out very recently by David Rose. I always believed that there were holes in the chart, but I had no proof of that. But he was showing that now very recently. So,
okay. So where do we go from here then?
Well, this is where we go from here. So many of my statistics colleagues have argued they could see exactly the same thing, and they would say, make the same arguments. And their viewpoint was, we should not have used this chart, and they're right. I mean, they're absolutely correct. It should not have been used, and we all agree upon that. However, it was used, and it was considered to be a very weighty piece of evidence. In fact, in my view, by far the weightiest piece of evidence, because even if we wish to agree that those with the medical evidence, that all of those wild theories about air embolisms and insulin poisoning and beating of a baby and overfeeding with milk, whatever we want to believe, nothing points to Lucy Letby. I mean, we'll say, okay, fine, there's all these horrible things happening. Somebody must have been responsible there. We don't know who. Why would it be Nurse Lucy Letby? So the only piece of evidence purporting to point to Lucy Letby was that chart. And since the chart is absolutely bogus as it is presented, then there's nothing pointing to Lucy. Now, the thing I wanted to do, which was something in addition to the statement that the creation of the chart is very problematic, I did realize that there is information nonetheless in that chart, which is interesting. So the line against Lucy Letby, of course, is not interesting. But what is interesting is when we look at any event and Lucy is chosen, there are other nurses there at that time. Now, that is valuable information, because with that information, and we have all of the nurses, all 37, I believe, that information enables me to work out the distribution of presence. By distribution, we mean the probability of being present for, there were 25 shifts there, so they could have been there never. They could have been there for 1, 2, 3, all the way up to 25. So
is that helpful?
It is. This is helpful. This is actually the same idea. We have the events. I have 36 events. So these could be the other events, the non-suspicious events. This table, by the way, has been generated. I, with a colleague, put this together. He put this together for me.
So this is not Lucy Letby data. This is
No,
data as an illustration.
as an illustration. It's simulated data, and you could do this a million times. The way we simulated it, we used the probability of presence for any nurse taken from the data we were just looking at. So any nurse, they were there, say, 5 times out of 25. So that would be 0.2. That's they have a 20% chance of being present. And well, here we use that same probability, only instead of 25, it's 36. And we use what is known as the binomial distribution. This is a very common, well-established distribution in statistical theory. And we can just generate a table, as I did here. Now, this table is just completely random, including nurse 23. Nurse 23, by the way, is nurse Letby. And we just randomly generate on that basis. Now, for her, of course, the probability would be 25 out of 25, 100%. So obviously I didn't use that because we're not making any progress. So what I did use was the average of the other nurses. The argument being, when non-suspicious events occur, there's no reason that Letby wouldn't be as likely to be present as anybody else. That's the argument. So of course we are making assumptions, as in any statistical analysis. You have to make assumptions, then you have to try and support them, back them up, argue and see how reasonable they are, number one. And number two, you need to investigate the impact they have on any conclusions you make. So it turns out we can make some pretty broad assumptions in the case of Nurse Letby, and they will not have a big impact on our final result. So here we have taken her to be about an average, let's just say an average nurse out of all of those nurses, some working rather more than others.
But looking at this chart, what I see, I mean, if you have a random chart of this or random data of this nature, looking down the bottom, you can see that some nurses will be appearing once, and other nurses appear 9, 10, 11 times. But this is a random feature. And it doesn't mean that the nurse who appeared 11 times is necessarily more guilty of anything than the one who appeared only once, does it? Or, I mean, what's the conclusion we're drawing here?
Yes, the nature of the randomness here does take into account the presence of that nurse for the suspicious, let's just call it suspicious data, the one we just showed, you just put up a minute ago, the 25 out of 25. We use that. So of course, even there, you could see some nurses were present rather more than others. Since they were more present for there we go.
Oh, well,
So
yeah.
since they're more present for the suspicious data than the let's call it non-suspicious data, they are going to that will be we'll get a reflection of that. So those nurses working the most will tend to show up as working the most again in this second part. And once more, this leans on a statistical assumption I am making, which I think is a very fair assumption, but that is the non-suspected nurses, their presence is independent of whether or not an event is deemed suspicious by Dowie Evans. So I think that's a fair assumption. They, of course, like all assumptions, are open to debate and discussion, but that's the assumption we were working with. And on the basis of that, we can get the complete chart.
So is that this one?
That is that one, and that is just random. So there's no effect. There's no nurse is unusually present when compared with all others.
Do you want to move on?
Please, just one more. Now, this chart is the same as the first one. It's just the same chart. But the reason I'm putting it up again is because I can affect the data here, whereas I couldn't with the original one was just a photo of the hummingbird report, and that was from their files. So that was just a photograph of that data, whereas this, we've recompiled it ourselves so we can play around with it, and that's what we do. And we look at the data, and then we'll see the implications of certain analyses, let's say.
So there were gaps in this chart which you're now trying to fill, is that right?
No, I'm not going to do anything. Well, yes, you're right, but not in this particular chart.
Okay.
If we go one more, you'll see this is exactly the same as the very first chart you showed. Here we go. Actually, we need to go one down. Let's go one more. Here we go. So this is the complete chart. So it stops. The red ones are the suspicious events on the left, the black ones, 36 non-suspicious events. So
these are all events, though. These are all areas where a baby was harmed or a baby died. 61 events, but only 25 of them have been chosen to be suspicious.
exactly, yeah. I'm not sure if I care for the word harmed. Something, let's
Something
say,
happened.
something
Something
happened.
happened.
These babies were very fragile. Things
Yes.
were going to happen, and they did. And this is just a number of that. This is just a cross section of that. Now, the top part, which is outlined in red on the left, that is the data. That's the first data we started with. That is the exact same data. The
Yeah.
bottom part is simulated data based on the assumptions I just described. Okay, and um, that will enable us to answer a certain number of questions.
Can I
If
just clarify? Well, you've simulated it because we don't have the original data, do we?
Exactly. Well,
Okay.
I don't think we can have all of it. I don't know exactly what we do have, and I don't have it anyway. I think Mark McDonald certainly has some of the data. Does he have all of this? I'm not sure if it would be possible because I think not all of that information on the other nurses. We have a lot of information
Yeah.
on Nurse Letby, but the information on the other nurses, I'm not sure how much of that we have.
So in the absence of the original full data, we have simulated, or you have simulated, based upon those assumptions that we made of randomness, the
Right.
remainder of the.
Exactly. Exactly.
Okay.
If you could go back one, because I wanted to mention, I'll say what this other chart is about here, because this is quite important. So I wanted to make this point here that the chart, as we saw with the iterations taking place, as described in the article in Unheard, um, when you start off with gaps, and then you can reassess them. So you look, for instance, there was one case of asphyxiation. And I think that was initially classified as suspicious. Well, of course, sounds like smothering. It would be hard to imagine a case that would be apparently less suspicious than that. That would sound suspicious. And I think initially it was deemed as being suspicious. But then, of course, it was discovered that Nurse Letby was not present. And not being present, well, then a reassessment was made and it was deemed actually not suspicious anymore.
This is
So
part of the iteration process you're talking.
that was the iteration process. And the point I'm trying to make with this chart here is that iteration process can be applied to any nurse. In this case, I'm applying it to nurse 14. And the process is really based on what the consultants, Jayaram and Brayeri, said when they were asked when they were first pointing the finger at Nurse Letby, what evidence they had against the nurse, and they recognized, both of them, they had no evidence of any kind, actually. The only thing they had were concerns, and later they said gut feelings. So I like to call this the gut feelings chart. This chart is based on gut feelings because when there is a gap or something that is inconsistent with your theory, then your gut feeling tells you, well, that's not quite right. So when the asphyxiation took place and Nurse Letby was not there, then your gut feeling tells you, well, you know what, that was probably non-suspicious. And the same applies, for both suspicious and non-suspicious. We just iterate until we end up with this chart.
Well, you
And
went for something which is essentially a selection bias, isn't it?
absolutely, absolutely. That's exactly right. That is the technical term used by epidemiologists to describe what is taking place here, selection bias. And had the consultants been focused on nurse 14 rather than nurse 23, they would have obtained this chart. And this chart could have been said then, okay, well, that other nurse, all the evidence looks very compelling against her. And of course, it's no more compelling than the other charts. So these charts are very misleading,
So
very misleading.
just to nail this particular point, if I can, selecting the 25 suspicious cases came out of the fact that Lucy Letby was known to be present at them. In fact, I believe one of the doctors was compiling a dossier on her, and that her name was therefore essential in compiling the chart. If all the nurses had been anonymous when you compile this chart, it's very unlikely that you would have come up with, say, 25 suspicious circumstances where Lucy Letby had been identified at all of them. That's where your probability is saying that it's extremely unlikely. But because it wasn't anonymous, because the nurses were not anonymous when the chart was compiled, selection bias crept in, and Lucy Letby's name was used as a pointer to what was suspicious.
100%, 100% agreed with that. That's exactly right. That's what happened. And we can call it selection bias or all sorts of different biases, outcome bias. What's the other term they use? They use many terms for this, but the point is, and they can really be sincere. You know, they can be quite sincere. Yeah. They look and say, it doesn't quite fit. It doesn't quite fit. But you end up with this. You will always end up with this kind of a chart. So what this chart really shows, and that's why I think they should be called gut feelings chart. This is a chart based on gut feelings. Those gut feelings enable the consultants and their colleague, Dowie Evans, and the police all working together to end up with this so-called smoking gun chart.
Yeah. Now, but the problem is it's the other way around. In other words, the suspicious circumstances didn't point to Lucy Letby. Lucy Letby was being used to point to suspicious circumstances.
Perfectly stated. I couldn't say it better than that. That's exactly right. That is exactly
right. So
it. Yeah.
You've got some other charts here. Well, this is the compiled chart. What did you do based upon that? What kind of analysis have you done on that?
Well, the first analysis is to ignore Lucy. Let's be open-minded, say Lucy could be guilty or not guilty. We're just going to ignore her. And we look at everyone else. I look at the remaining 37 nurses. On the basis of their presence, I filled in the second part of the chart, you know, the non-suspicious. That was filled in using techniques developed by Donald Rubin, who's a world authority, statistical authority, and it's how we deal with missing data. So I dealt with this as a missing data problem. Okay. And of course, we cannot know what the data is, you know, because it's missing. But we can say certain things about the probability of various configurations. Now, if we look at that, there are, I was going to say billions, but there's probably far more than billions of potential configurations. We can work it out. It's a combinatorial problem, but it's a very large number of potential configurations that there could be. But what we can do, we can put a probability distribution on that using the techniques of Rubin and Little. These are, you know, this is well known in the field of statistics. And what we then obtain, and that's the next slide, if you want to go down, Philip, exactly, this is what we get. So if we can fit this model now, so we're going from 0 to 61 shifts. This is based on a distribution known as the beta binomial distribution. It's very standard elementary distribution in epidemiology. I mean, it's not going to be known to non-statisticians, but I would say every statistician would have some familiarity with the beta binomial distribution. The shaded area is the raw data. So how many events, I'm sorry, how many presences, how many shifts was a nurse present for? And that's the distribution we got. There is showed there. And the probability of being there for those different numbers. We fit the beta model to that. And if you want to go down, and the fit's good, and we did all of the tests on that. You can do a lot of tests. How good is the fit? And it was good. And so this is what we get here. We look at the 61 events. What is the probability for the 61 events of any randomly chosen nurse ignoring Lucy? We keep Lucy out of it. Just a randomly chosen nurse. And this is the distribution of events. So in other words, if you want to know what is the probability of seeing 25 events or more than 25 events for a randomly chosen nurse other than Nurse Letby, it's that area in red. It's 25 and above. And the first thing we can note is that's tiny. I mean, it's very small. And I'll give the number there. I'm not sure how readable it is. Excuse me, 0.013.
Yeah.
1.3%. And given that there were 37 nurses, it's quite likely that no nurse in that collection of nurses had any ability to even make the 25 events, whether they're suspicious or not. Just put them
Okay.
all together.
But
Sorry.
wait a moment though. Doesn't that then make Lucy Letby's guilt more evident? Because she does have 25 events and even more in the simulated area. As she has 25 events against her name, doesn't that put her into the red group? And doesn't it make it very suspicious that because there's only a 0.01.3% probability that she must be the person who did it? Have I read that right?
I think so. I think that's quite accurate. But we'll need to dig a little more deeply nonetheless. That's a good point. And the thing is, we can work out the probability distribution for Nurse Letby. And the way we do that, of course, the ridiculous calculation of 25 divided by 25, 100%, it is ridiculous. It's all based on selection bias, as we pointed out. So we ignore that, but we can get an angle on it using techniques we call them survival analysis techniques, again, very familiar to epidemiologists. And essentially what it's saying is that there is a relation between the probability of Lucy being present and the probability of a randomly chosen nurse being present. It may be greater, it may be the same. Let's investigate. And that's what we can do. And we can work out that relative risk. I did work it out, or my colleague worked it out. And what we see, if we can go a little further down, okay, sorry. Can we go up? Did I miss something? Can we go up? No, keep going up. What? Up, up, up. The previous, okay, sorry. Yes, what we want, and it's the point you've just made, we want to know where does Luce Letby fit onto this. So what we do, this is what we have here is a probability distribution, but we want a probability, a survival curve, and that's simply says, and the next one shows us that. I'll describe it. If you just go down one, there we go. So let's just look at the top. Forget the bottom one. Just look at the top one. What?
Blue one.
No, the black
Oh no,
one. We'll start off.
The top chart. Sorry.
Sorry, the top figure. Yeah. The black line. Now, the black line is exactly the same information than what we've just seen. Exactly the same. It's presented differently. So the one we were just looking at tells me on a certain shift, what is the probability of a randomly chosen nurse being there? This one is not saying a number, it's saying a number and greater than that number. So what is the probability of a nurse being present for 0 shifts or more? Well, it's 100%, obviously. What is the probability of a nurse being present for 10 shifts or more? And that chart gives it. And of course, that is going down as you expect. As the number goes up, that number goes down.
About 0.5 looking at this.
I'm sorry?
About 0.5.
Yeah, we can read it. We just read it off. Those are the events, the dots corresponding to those numbers. And if we use that, we get the exact same number, the 1.3% for the black line. Now, Lucy Letby, we can work out using different techniques. As I said, I can use techniques of epidemiology based on relative risk. I can estimate the relative risk using the assumptions we've described earlier on. And this is what we find for Nurse Lucy Letby. We find the blue line, and which ends at 25. They both end at 25. We curtail the distribution at 25. And if I compare the blue line to the black line and use statistical terminology, this is highly significant. So Nurse Lucy Letby, as you just pointed out, is very different to everybody else. That's clear. And in actual fact, if we look at 25 events or more, what we find is the 1.3% for everyone is more like 10.5%. I think 10% around there for Lucy Letby. So it's about 8 times higher.
So
Uh,
why are you not saying that therefore this is damning evidence against Lucy Letby?
Well, I'll say the very opposite, actually, and
Yeah, yeah.
we need
What
to
why?
get there in one quick second. Now, those charts, they've been curtailed at 25, and what I can do is I can work out the area under the curve, and I'm
Yeah.
trying to show that in the pictures.
Yeah.
Um, that is the area under the curves. Now,
What does
that
that do
area
then?
under the curve, actually, in survival analysis theory, it tells you that given it's got to be less than 25, it gives you the mean number of shifts worked of presence. And of course, overall, we find that's the AUC, area under the curve. For everyone, it comes out, if I can read correctly, I think it was 9.9.
Yeah.
Whereas for nurse Lucy Letby, it turns out to be 13.6, a good deal greater than the others. And as I said, we can test those things as significant, etc. But let's ask ourselves the following question. I am comparing nurse Lucy Letby with everyone, with a randomly chosen nurse. How about if instead of that, I compare Lucy Letby with a subset? I'm going to compare her with nurses who work more than the average. So if we go down a little bit, we'll see how this looks. There we go. Perfect. So the top left-hand curve is the one we started with. The top right-hand curve is the second one we were looking at. Now, the bottom left-hand curve corresponds to those nurses who were working 20% more, 20% more than the average. Okay?
Yeah.
The blue curve has not changed. That's Nurse Letby. That doesn't change. But already we can see straight away the means have got much closer together.
Yeah.
And of course, we can just visually, you can see that the black line is approaching the blue line. Now, the bottom right-hand curve takes it one step further. So I look at all those nurses, just that subset of nurses who were working 1/3 or more than the average. So this is a lot more than the average. What happens? Well, there's no difference at all. The difference has completely disappeared. And of course, what we're seeing here is that the amount of time on shift is an absolutely crucial factor, of course, in the whole thing. And we know from internal information we have about the Countess of Chester, the nurse Lucy Letby was working at least 1/3 more than the average. Keep in mind that that average is sometimes brought down by agency nurses, nurses who were not working a lot. And so the average is not a representative figure necessarily. But in any event, if we compare nurse Letby with only those nurses working 1/3 or more than the average, then there's no difference at all. And we do know the nurse Letby was part of that group. She was working at least 1/3 more than the average.
And that's utterly remarkable here because what you've shown from these figures and from this statistical analysis is that Lucy Letby is singled out not because she is more highly suspicious than others, but simply because she worked harder than anybody else, that she was 1/3 more on more shifts than average. And that's what brings everybody who would do that up to the same level of curve that she's on. It's like
Absolutely. Yeah,
it's
absolutely.
identical.
Absolutely, absolutely. And in actual fact, you can work out, and we did work out how many nurses were in that situation, if you like. How many were working that amount more than the average? And what we find, I think it's around 5 or 6 nurses. So Nurse Lucy Letby was not necessarily the nurse that even worked the most. I think she
Yeah.
was singled out. Well, I don't need to get into that too much, but there may be other reasons why she was singled out. Not because she worked the most. She was certainly among those working the most. No doubt about that. She was among the nurses working the most. But she may not have been. There could have been 1 or 2 other nurses who were present anyway, let's say, more frequently than she was when something deemed suspicious by Dowie Evans took place.
Okay.
So,
So
so the police should be, either they interrogate those nurses They should be carrying out their investigation there, unless, of course, they come to another conclusion, which I think more and more people are coming to, which is that no crime ever took place.
Yeah. So any nurse at all, which worked 1/3 more shifts than the average, would have ended up with a profile just like Lucy Letby's if they
Yes,
select out the with selection bias the appropriate
yes,
number of events.
yes, absolutely, absolutely.
There's nothing to distinguish Lucy Letby then from
No,
anyone else, other than the fact that she worked more shifts. So if we've got rid now of the medical evidence, because 14 experts have said that there is no medical evidence against her, and if, as you've pointed out, there is no statistical evidence against her either, and that these events are not necessarily due to suspicious events at all, then what is left to condemn Lucy Letby?
there's nothing. There's nothing left at all. I think more and more people are getting to realize that this nurse is sitting in prison without having done anything wrong. No, there's nothing, but that's the question now is a different one. The question is, how can she be released from that situation?
Going to
And
go
of
on
course, I'm
to ask
sorry.
where we go from there, because last time we spoke, and we spoke about the case in some detail, I made the statement that, as far as I was concerned, I had an open mind on the matter. I didn't know whether she was guilty or whether she was innocent. You were more convinced than I was, but I have to say that having seen this particular evidence that you presented now, I've changed my mind on that. I have to say that I don't think that she is guilty. Certainly, I don't think there is any evidence which is beyond reasonable doubt which would convict her in any honest court of law. So the question is, where do we go from here? I mean, what would happen
Well,
should happen next in the Letby case?
Well, it's with her attorney, of course, and she has a lot of supporting and a growing number of supporters and people indeed that I know who have changed their mind. I mean, I knew people who are absolutely convinced of her guilt and are changing their minds. So I think public opinion is changing, and I think that can help. There is a problem, and in a sense, it's not directly related. I mean, indirectly, of course, it relates to Nurse Letby, and that is the horribly slow degree of rectifying things if there have been judicial errors. There is no quick path to take. And I'm not a jurist, I'm not that familiar with things, but when I explain to people, certainly in France, I don't know about France either, to be honest, but and who knows how it works here, but when I tell people that when Lucy appealed and they said, well, how did she lost her appeal? And I said, well, you know what? She didn't actually lose her appeal. She wasn't even allowed to appeal. So, well, how is it possible you're not allowed to appeal? I said, well, you have to apply. And if they do not allow you to appeal, then you just simply don't appeal. And then once that has happened, then the only thing left to you is what is it called? The CCRC.
The Criminal Cases Review Commission.
Yeah, which, as we know, and there are famous cases now, very famous cases where the innocence of somebody was known 15 years before they were released. I mean, it's absurd. It really is absurd. And certainly people are getting to see it has nothing whatsoever to do with justice. Certainly Lucy Letby will have suffered horribly, and many other people, reputation, many people are suffering as a result of this. But one entity, body, if you like, which is suffering, is the whole judicial system is going to take a massive blow. I'm not sure who it was. Somebody was telling me about surveys that were carried out in England over the last 30 or so years about the confidence people had in the judicial system. And it's collapsed. It's completely collapsed. Of course, because of several cases, famous cases, obviously the post office in many ways was even more absurd. I mean, it's so incredible that could take place.
There's
And
an old legal maxim that justice delayed is justice denied. And there certainly
yeah,
have been delays in these kind of cases. Very
yeah,
similar cases that you mentioned last time. A case very similar to this in Belgium, where I think the woman was in jail for 6 years before they released her and exonerated her completely. Another
no,
woman in Italy,
in
the same
Italy, yeah,
kind of issues and problems. And again, not released for many, many years. Sally
yeah,
Clark in this country, accused of murdering her own children, again, completely exonerated, but after
yeah.
3 or 4 years in prison. And as
She
a
died, yeah.
consequence, her
It killed
life
her.
totally wrecked. And I think she committed the equivalent of committing suicide with an overdose of alcohol
Yeah,
poisoning
yeah.
after she left. And all of these are tragedies, partly because delay in justice in getting these things sorted out. It wouldn't surprise me if this kind of case still takes 2, 3 years before she's released.
I mean, that would be horrible. This
Yeah.
is a woman in obviously in her prime. She's a young woman. She's in her mid-30s, but it is an age when people are settling down or already settled down and thinking about building their lives. And that has been taken from her one way or another. It's been taken from her. But if they would like to leave her with something, then she should be released, essentially immediately, in my view, given everything that's been said and the given, the fact that those convicting or what should I say, arguing in favor of the conviction, and in particular, expert witnesses like Dowie Evans, they have totally discredited themselves because they've changed their stories so often
Yeah.
and come up with different angles, different ideas. It's just not credible. So the prosecution's case is not credible, whereas the opposition's case is credible and very strong and should be listened to. And I don't know. I mean, I don't know. Mark McDonald would know better. What remedies can be sought? Obviously, he's doing everything he can. I mean, he certainly looks like a very, very brilliant and competent attorney. So I do think she's in good hands there.
Well, the
What
more
they can
people I
do, I
think
don't know.
that bring this out into the open and consider it from the different angles and present the view on the matter and the evidence that clearly her case has been a miscarriage of justice, then the
Yeah.
better. And I think that your work here has just helped along that way, particularly looking at the statistical side. The others have looked at the medical side. Now it seems to me you've taken care of the statistical side. And let's hope that that can bring some justice to bear sooner rather than later. So, John, and quickly, thank you
Mm.
ever so much for going through this with us. And let's hope that it has some real effect. Thank you.
Thank you, Philip. Nice talking.